In this module, we are going to discuss about the introduction to mathematical economics. What is the meaning of mathematical economics? What are the uses of mathematical economics? And the various terms and terminologies used in mathematical economics are briefly explained in this section. We know that mathematical economics is a model of economics, and it utilizes mathematical principles and methods to create economic theory as well as to investigate economic phenomena. That is, it is a model of economics and it utilizes mathematical principles and methods for what? For the creation of economic theory as well as to investigate the economic phenomena. And it permits economists, or the mathematics helps economists to conduct quantifiable tests and create models to predict future economic activities. That is, the mathematics helps economists to test the propositions and also to predict the future of economic activity. These are the importance of mathematics, or what mathematical economics do in economics. It is a form of economics that we have already seen, and it relies on quantitative methods to describe economic phenomena. That is, in mathematical economics, we describe economic phenomena using the quantitative methods. And here, these methods, or this can be used for in the various field of research. And in the field of the research, the mathematical economics can be used to test the theory, and it also helps in the field of economic policy decisions also. That is, this mathematical models helps to assess the impact of economic policy. That is what we have explained what we have explained so far is that mathematical economics is the application of mathematical methods to represent theories and analyze economic phenomena or economic problem. That is, it applies mathematical methods to represent theories and analyze the problems in economics. That is, we uses various mathematical methods to represent the theories as well as to analyze the problems. We uses methods like geometry, differential calculus, differential equations, differential methods, integral calculus, differences, differential equations, matrix algebra, mathematical programming, etc. for representing as well as to analyze the economic problem. Then what are the advantages of mathematical economics? Here, the advantages of mathematical economics, that is, we know that in mathematical economics we uses mathematical methods to represent as well as to analyze the economic problems. Then what are the advantages of representing these economic theories in terms of mathematical, or by using the mathematical models and methods? First one is the language used is more precise and concise. That is, we can represent an economic theory in a more precise and concise form. That is, the law of demand explains the inverse relationship between the quantity demanded and the price. It can be represented very simply as QD equal to A minus BP. That is, it is very precise and concise. That is, we can represent the economic theory in a very precise and concise manner. That means that the language used is more concise and precise. Second one, a number of mathematical theorems helps us to prove or disprove economic concept. That is, in order to prove or disprove the economic concept, we can use the mathematical theorem. This is the second advantage. Third one is it helps us in giving focus to the assumptions used in economics. We know that in economic theory we uses a number of assumptions, and these assumptions can be focused, or this can be proved or disproved by using the mathematical methods. And the fourth advantage is that it makes the analysis more rigorous. That is, we can make the more rigorous analysis of economic phenomena by using the mathematical methods and models. Fifth one is it allows us to treat the general and variable cases. That is, we can generalize these economic theories by using the mathematical models and methods. That is, unless in economic theories, we know that the number of variables is very limited, but it can be generalized using the mathematical models and methods. This is some of the important advantages of mathematical economics. That is, it gives precise and concise form of economic theory. Second one, it helps to prove or disprove the economic concept. Third one, it helps in focusing the assumptions. Fourth one, it makes the analysis more rigorous. And fifth one, it allows to it helps to generalize the model or the economic analysis. Some of the limitations of the mathematical economics are explained here. First one, untimely use of mathematics may be worthless. Especially the economists like Alfred Marshall criticized the excessive use of mathematics, even though he used mathematics in his principles of economics very extensively. But he advocated for the use of short and simple use of mathematics in economics in a very short and simple manner than in a very complex form. And according to him, the use of mathematics as a shorthand language rather than an engine of inquiry. That is, use of mathematics should be to simplify as well as to shorten the economic phenomena. In this section, some of the terms and terminologies used in mathematical economics are given. The first one is the economic model. We know that a model is a simplified representation of an economic reality. That is, in a model, we simplify a reality. And an economic model is a simplified version of reality that allows us to observe, understand, and make prediction about economic behavior. That is, in economic model, it is a simplified version of reality, and this helps to observe, understand, and make prediction about the economic behavior. And the purpose of a model is to take a complex real-world situation and pare it down to the essential. That is, this economic model helps to reduce a complex model into a very simple model. An economic model is an organized set of relationship that describes the functioning of an economic identity under a set of assumptions from which a conclusion or a set of conclusion is logically derived. That is, it is an organized set of relationship which describes the functioning of an economic identity, and it is backed by a set of assumptions from which we derives the conclusion. That is, in an economic model, we can see a set of organized relationship which explains or describes the economic identity under a set of assumptions. And it also gives the conclusions or a set of conclusions which is logically derived. And the expression of the model can be in the form of a word, diagram, or mathematical equation. And an economic model, in short, represents an economic reality. It may be in the form of a word, diagram, or mathematical equation. This is about the economic model. That is, the economic model explains the behavior, explains the relationship between a set of variables which is backed by assumptions from which the conclusions or from which the conclusions are logically derived. Another term is microeconomic model and macroeconomic models. Microeconomic models study the individual unit of the economy like the consumer, firms, and factors of production. That is, we know that in economics we have two branches of economics, microeconomics and macroeconomics. Microeconomics mainly deals with individual firm, etc., or their analysis, and macroeconomics mainly deals with the aggregate or the whole economy. And macroeconomic model studies the behavior of individual units of an economy like consumers, firms, factors of production, etc. And in macroeconomic analysis, we study the aggregate consumption, aggregate investment, national income, general price level, etc. That is, it is an examination or it is a representation of the aggregate, and it is mainly used for studying the working of the whole economy and mostly employed in economic planning. And the economic model is divided into two. We have seen that there are two types of economic model, microeconomic model and macroeconomic model. One deals with individual and firm level analysis, the other one with the aggregate economic activity. And the economic model itself can be divided into two. They are partial equilibrium model and general equilibrium model. In a partial equilibrium model, two or more variables are selected while the rest are kept constant. That is, it takes into account only a part of the economy or part of a problem or part of the market. Whereas in a general equilibrium model, it is composed of all variables of the economy. It attempts to explain the behavior of supply, demand, and price in the whole economy. That is, in a partial equilibrium analysis, we analyze as part of the variable, whereas a general equilibrium model explains the whole it takes into account all the variables of the economy. Here, in this section, the methods of study of the methods of methods of studies used in mathematical economics are given. We use two approaches for the study of mathematical economics, or we use mainly two methods for deriving an economic theory and for the testing. They are deductive method and inductive methods, and both methods comes from the science, that is the logic. And the deductive method involves reasoning from a few fundamental propositions, the truth of which is assumed. The inductive method, on the other hand, involves collection of facts, drawing conclusion from them, and testing the conclusions. And in deductive methods, it involves reasoning from a few fundamental propositions, whereas in inductive methods, it involves the collection of facts, drawing conclusions, and testing. Deduction starts from the general and moves to the particular conclusion, begins with a general assumption and moves to a particular conclusion. It develops a theory and then examines the fact to see if they follow the theory. That is, in a deductive method, we start from a general and derives a particular theory or proposition. It involves four steps. They are selecting the problem, the formulation of assumptions on the basis of which the problem is to be explored, the formulation of hypothesis through the process of logical reasoning, and verifying the hypothesis. These are the four steps involved in the deduction. They are selecting the problem, formulation of assumption, formulation of hypothesis, and verification of hypothesis. The next method is the inductive methods. In inductive methods, in contrast to the deductive method, we starts from a particular and moves to the general. We begins with the particular observations and moves to the general explanation. We collect observation and then developed a theory to fit the fact. And it involves the collection of the problem or generalization of the economic problem, collection of data, its enumeration, classification, and analysis. And third one is the generalization, that we start from a particular and we ends with the generalization. This about the two important approaches used in mathematical economics, that is deductive and inductive methods. Here in the following section, the ingredients of mathematical models are given. That we know that if a model is mathematical, it will consist of a set of equations which describes the structure of the model by relating a number of variables to one another. The various concepts used in mathematical economics includes variables. The first one is variable, then next one is a constant, parameters, functional relationship, then various forms of the equations, etc. are various ingredients of the model. The first one is variable. A variable may be defined as something whose magnitude or quantity can change over a specified time period under consideration. That is, it can assume different values which are generally specific. A variable is a term, or a variable may be defined as something whose magnitude will change. And a model includes dependent and independent variable. Then what is it's a dependent variable. A dependent variable whose magnitude is related in some unique way with the changes in the magnitudes of some other variable. In the demand function, demand is the dependent variable. It depends upon the factors like price, income, taste, etc. That is, in this, the magnitude of, in the case of the dependent variable, the magnitude is related with the changes in the magnitude of some other variable. That is, it depends upon the changes of some other factors. An independent variable, on the other hand, are variable whose magnitude or values are determined externally. In this case, the values will be, or in the case of the independent variable, the values will be determined externally. In the demand function, the independent variables are price, income, taste, etc. Its values will be determined outside the model. That kind of variables are known as the independent variable. And the second term is the constant. A constant is something whose magnitude does not change. For example, we'll say x, y, a, b. These are constant. When a constant is joined to a variable, it is called the coefficient of that variable, ax. In that, the a is the constant, x is the variable, then a is known as the coefficient. Then, for example, the equation x plus by equal to c. Here, a and b are the coefficient of the variable x and y. 5x plus 4y equal to 6x. Here, 5, 4, 6 are coefficient and x, y and z are the variables. Next term is the parameter. Parameter is a symbol which is constant for purpose of any particular problem but may assume different values in different problems. It is represented by A, B, C, or by the Greek letters like alpha, beta, gamma, do, etc. These are the parameters. It's a symbol which is constant for a particular case but may vary in depending upon the other situations. Another term is functional relationship. A functional relationship between two variables exists when a change in the value of one variable uniquely determines the change in the values of another variable. That is, change in values of one variable determines the change in the values of another variable. For example, y equal to fx. It is simple single variable model. Y, a function of kl, is a multiple variable model. That is, when a change in one of the variable results into a change in the other variable. Such relationship is known as the functional relationship. Another term is the equation. In economic model, there are three types of equations. First one is definitional equation, second one is the behavioral equation, and third one is conditional equation. What is a definitional equation? A definitional equation specifies a relationship between two alternative expressions having the same meaning. That is, a definitional equation is simplified by the three parallel lines. Behavioral equation specifies how a variable behaves in response to the change in variable, and it is based on certain assumptions. And the third type of equation is conditional equation. It states a requirements to be satisfied. When a model involves the study of equilibrium, the equilibrium that explains the attainment of equilibrium is called the equilibrium condition. That is, QD equal to quantity demanded equal to quantity supplied. This is conditional equation. Saving equal to investment. That is, it requires certain requirements to be satisfied. Then the process of model buildings are explained here. This include define the problem, that is, define the problem about which the model is to be built, formulate equation, identify the variable. Second one is formulate the assumption. Third one, collection of data. Fourth one, derive the hypothesis. Fifth one, prediction. These are the various process of model building. Define the problem, formulate the assumption, second one, then collect the data, derive the hypothesis, and make the prediction. Then what are the limitations of economic models? First one, economic models are not comprehensive. They are partial. Second one, they tend to neglect those factors that prove difficult to quantify. If a factor is difficult to quantify in the economic model, it will be neglected. Another limitation is that when expressed in terms of mathematical models, it lacks relevance and reality. These are some of the limitations of mathematical or economic model. In this section, various types of the functions are explained. First one is algebraic function. A function is called an algebraic function if it can be constructed using algebraic operation. We have different algebraic operations like addition, subtraction, multiplication, division, and roots, etc. A function is called algebraic function if it can be constructed using the algebraic operations. Polynomial function, power function, rational functions are all algebraic function. We use as various algebraic operation in all these cases. In a polynomial function, a function p is polynomial if p of x equal to a n x raised to n minus 1 x raised to n minus 1, a 2 x raised to 2, a1 x plus a0, where n is a non-negative integer and a0, a1, a2 to an1 minus 1 are all constant called the coefficient of the polynomial. A polynomial of degree 1 is called a linear function. A polynomial of degree 2 is called a quadratic function. A polynomial of degree 3 is called a cubic function. A polynomial of degree 4 is called a quadratic function. A polynomial of degree 5 is called a quintuple function. These are the various functions. And what are the different types of the functions that are frequently used in economics? First one is linear function. If the exponent of the variable is 1, then it is known as the linear function. In the given example, fx equal to a plus bx. Here the exponent of the variable is 1, therefore it is a linear function. Second one is quadratic function. If the power of the highest power of the variable is 2, then it is known as quadratic function. And the polynomial function can be specified as we have already seen. And the rational function expresses the two common terms in terms of the ratios. Examples of various functions are given here. Y equal to 5 is a constant function. Y equal to 5 plus x is a linear function since the power of the variable is 1. Here this is an example of cubic function. This is an example of rational function. It is expressed in terms of the ratios of two variables. This 4x e raised to x is an exponential function. Y equal to ln x is the logarithmic function. We have another types of the function, namely the non-algebraic function. We know that in algebraic function we make use of the various algebraic functions. In all algebraic functions, this include exponential, logarithmic, trigonometric functions, etc. Algebraic functions can be in the form of the constant function, polynomial, rational function, etc. A constant function is a function whose range consists of one specified value. That is, y equal to fx equal to 6. Here, range consists of one single value, specified value. In a polynomial function, we have different degrees, and depending upon the degree of the linear variable, we specify the function, or we name it as either linear function, if the degree is 2, quadratic function, if the highest degree is 3, then it is the cubic function. A rational function is function which is expressed as the ratio of two polynomial functions in the same variable, that is xi minus 1 divided by xi minus 2x minus 1. And the non-algebraic functions include exponential and logarithmic function. These are the various terms and terminologies used in mathematical economics. And it consists, here we have explained what is mathematical economics, what are the various advantages and limitations, what are the major ingredients of mathematical